You ever see a car crash and it looks just awful? And you wonder, how did anyone walk away from that? Well, I can tell you, it's not luck. It's all about physics. And today, we're going to dig into the hidden science that keeps us safe. This is the physics of survival.
Yeah, a high-speed collision. It's a terrifying thought, right? And it brings up this huge, really complex question. How do you survive something like this?
So the answer, it's not magic. It's not some miracle. It's all physics. It really comes down to controlling the absolutely huge forces that are unleashed during a sudden, violent stop. Every single safety feature you see here, the seatbelt, the airbag, even the way the car's frame is built, it's all a direct result of us understanding and using the laws of physics. Okay, so to really get how engineers protect something as complex as a human body, we're going to simplify things a lot. We're going to start with a much more delicate challenge. Our mission, if you choose to accept it, is to use these simple craft supplies to save an egg. All right, so let's get into our little crash test simulation here. The whole puzzle is this. How can we take this cart, stick an egg right on the front, and set it smashing into a solid wall, and have that egg come out completely fine? Not a single crack. How do we do it? Now, of course, any good experiment needs some rules, right? So here are ours. 1. The egg has to be right on the front. 2. The cart has to make full contact with the wall and come to a complete stop. And 3, and this is the important part, we can build a bumper to soften the blow, but we can't do anything to the egg itself. No supergluing the shell or anything like that. The egg has to take the hit as is. So, how do we even start to build this life-saving bumper? Well, the instructions, the blueprints, they come from 3 of the most fundamental laws in all of science. Newton's laws of motion. These are the clues that are going to help us crack this case. Okay, let's kick things off with law number 1, the law of inertia. All this really says is that things want to keep doing what they're already doing. Simple enough. So, when our cart slams into the wall, the cart itself stops, right? But the egg? Well, the egg's inertia means it wants to keep right on moving forward, and that is the absolute core of our problem. You know this feeling. You've felt it a million times. You're in a car, the driver slams on the brakes, and your whole body lurches forward. That's your inertia at work. Your body, just like our poor egg, wants to keep moving at the same speed. It's your seatbelt that provides the force to stop you. That feeling of being thrown forward, that is inertia in action. Okay, on to the second law. And listen up, because this one is the key to our entire challenge. Force equals mass times acceleration. F equals ma. It's so simple, but this little equation governs basically everything that moves in the universe. It tells us that the force an object experiences is just its mass, how much stuff it has, multiplied by its acceleration, which is just how quickly its speed is changing. So this relationship is everything. Look at it this way. A big, destructive, egg-shattering force, well, that comes from a really big acceleration, a sudden stop. So if we want to protect our egg, we need to create a small force. And think about it. We can't change the mass of the egg, right? So the only thing we can possibly change in that equation is the acceleration. We have to reduce it. So, okay, our goal is crystal clear. We have to minimize the forces on the egg. And because we know F equals ma, we know that really means we have to minimize the acceleration. But that leads to the really big question. How in the world do we actually do that? And that brings us to the final piece of our physics puzzle, Newton's third law. For every action, there's an equal and opposite reaction. You've heard that one before. So when our cart hits the wall, it pushes on the wall. But here's the thing. The wall pushes back with the exact same amount of force. And it's that massive pushback from the wall that brings our cart to that sudden, violent, and very egg-shattering stop. Oh, and it's really important here to quickly clear something up, the difference between mass and weight. People mix these up all the time. Mass is just the amount of stuff in an object, and that never changes, whether you're on Earth or the moon. Weight, on the other hand, is the force of gravity pulling on that mass. In our big F equals ma equation, that m stands for mass, and that's the thing about our egg that we absolutely cannot change. Okay, so we've got the theory down. We understand the basic physics of how to save a fragile little egg. So now let's scale this whole thing up. Let's see how these exact same ideas are used out in the real world to save human lives. I mean, look, a car weighing thousands of pounds crashing into a wall. It's literally our egg challenge, just on a massive, massive scale. The auto engineers, They're solving the exact same problem we are. How do you stop this huge object that's carrying a very fragile payload, that's us, without hurting it? The only difference is the forces involved are just astronomically bigger.
And the solutions they've come up with? They are absolutely brilliant applications of physics. You've got crumple zones, seatbelts, airbags, even the headrests. Every single one is a device designed to manipulate the forces of a crash, and it's all based on those same Newtonian principles we just talked about. And here's the perfect connection. Look at a car's crumple zone. It is designed to do one thing: collapse and absorb energy. The craft supplies we have for our egg bumper, they're for the exact same purpose. That crumpled up metal you see on a crashed car, that is our bumper, just on a much, much bigger scale. Okay, so here it is. Here's the secret sauce. Remember how we said we need to reduce acceleration to reduce the force? Well, think about what acceleration actually is. It's the change in speed over time. So by designing the front of the car to crumple, what engineers are really doing is increasing the amount of time it takes for the car to come to a stop. A longer stop means a slower deceleration. And what does F equals ma tell us? A smaller a means a drastically lower F, a survivable force for the people inside. It's all about buying more time.
All right, we've got all the pieces of the puzzle now. We understand the challenge with the egg, we've walked through the physics, and we've seen how it applies in the real world with cars. So let's bring it all back home and officially solve our egg crash test.
So here's the whole thing step by step. The problem? A super sudden stop means a huge acceleration, which creates a lethal force. The physics, F equals ma, tells us, point blank, that to lower the force, we have to lower the acceleration. And so the solution is to build a bumper that acts just like a car's crumple zone. It needs to absorb energy, and, this is the most important part, it needs to stretch out the time of the crash. We turn a sudden catastrophic stop into a longer, much gentler, and survivable one. You know, your first instinct might be to build a really strong, hard bumper, right? Something that won't break. But the physics tells us that is the absolute worst thing you could do. A rigid bumper just transfers all that force instantly. So the secret to survival, it's not about being strong. It's about being smart. It's about designing a system that gives way, that crumples, and that cleverly buys you more time during that impact. So there you have it. A few simple laws of physics can protect something as fragile as an egg and something as precious as a human life. It kind of makes you wonder, doesn't it? With everything we're learning about physics, what's the next big revolutionary safety feature that's just waiting to be discovered? What's just around the corner? Definitely something to think about. Thanks for digging into this with me today.